Hello everyone, today we are tackling a classic high weightage problem that mixes trigonometry with a little bit of calculus. We need to find the sum of all integral values of p so that the equation 3 sin square x plus 12 cos x minus 3 is equals to p has at least one solution. Let's rewrite given equation in terms of cos x which is minus 3 cos square x plus 12 cos x is equals to p. We know that for x belongs to real numbers, cos x belongs to close interval minus 1 comma 1. So let cos x is equals to m. So our f of m is equals to minus 3m square plus 12m is equals to p. Now we have a simple quadratic equation. We need to find its maximum and minimum value to find the range of p. To do this quickly, let's take the first derivative with respect to m. We get f dash of m is equals to minus 6m plus 12. The highest value of m is 1 and f of 1 is equals to 6, which is greater than 0. Since f dash of m is greater than 0 for our entire interval, this function is strictly increasing. That means no complicated critical points to find. So minimum of f of m is equals to f of minus 1, which is equals to minus 15, and maximum of f of m is equals to f of 1, which is equals to 9. So p can be any integer from minus 15 to 9. Don't waste time adding every single number. The positive number from 1 to 9 will completely cancel out the negative numbers from minus 1 to minus 9, and all you left is minus 15, minus 14, minus 13, minus 12, minus 11, minus 10. And adding these, we will get minus 75. And this is our final answer.